Hello, my name is Kaylee, and this is my physics video project. For this experiment, I studied how a toy car's speed changes over time as it moves down a ramp. My research question, or what I was trying to find for this experiment was, what is the relationship between time and velocity for a toy car rolling down a 20-degree incline? Basically, I wanted to see how the car's speed changed as it moved down the ramp. Hypothesis. So I predicted that if the toy car starts from rest and moves down a 20-degree ramp, its velocity, or speed in a certain direction, will increase over time. Since gravity pulls the car down and there's little friction, I expected the speed to increase at a steady rate, meaning the acceleration would stay the same. This should create a straight, upward sloping line on the velocity versus time graph. Materials. To test my hypothesis, I used a Hot Wheels track that was 52 centimeters long, a toy car, books to create the 20-degree angle, a meter stick to measure distances, a protractor to check the angle, and Logger Pro software to analyze the data. Setup and procedure. I set up the track on a stack of books to create the 20-degree incline. Then I placed the toy car at the top of the ramp and let it go without pushing it. So you can see here that this is where the car starts and this is right around where it ends. And then I used Logger Pro to analyze how the car's velocity changed over time. So I've got the video here. Alright, I'm going to start out by defining the meter stick here. 1 meter. And after that, I'm just setting up the axis based on the position of the toy car. And finally, I just started plotting my points here as it sets up the whole graph and table for me. This class is the first class that I've had to use a software program like this, and I really enjoyed it. I found it pretty cool and easy to work with for the most part. So I'm just going to let myself finish plotting these points here. Alright, now that that's done, here is the finished graph that it gave me. Alright, velocity versus time graph. This graph shows how the car's velocity changed as time passed. The graph forms a straight upward sloping line, meaning the car sped up at a constant rate. And this supports my hypothesis that the acceleration would remain steady as the car moved down the ramp. So for this part of the project, I used Logger Pro data to calculate acceleration based on the car's motion down the incline. First, I found the quadratic fit equations for both the x position and y position up here. And then these equations describe how the car's position changed over time. And since the motion follows the equation right here, we can compare it to our equations and solve for acceleration. So using the formula right here, this a equals 1/2 right there, I calculated the acceleration in both the x and y directions, and these are the answers right here. The horizontal acceleration shows how the car is speeding up along the track, and the vertical acceleration, it's small compared to gravity because the motion is mostly along the inclined plane rather than directly up or down. But overall, these calculations confirm that the car is accelerating in the direction of the incline, just as I expected in my hypothesis. So there are some sources of error. Even though my results followed the expected pattern, there were possible errors. So the friction between the car and the track, or air resistance, might have slightly changed the results. However, these factors were small and did not change the overall pattern. Conclusion: in the end, my experiment supported my hypothesis. The car's velocity increased at a steady rate just as I expected. This happens because gravity pulls the car down the ramp, causing constant acceleration. So even with small errors, my results clearly showed the relationship between time and velocity for an object moving down an incline. Thank you for listening, and I hope you enjoyed my video project.